Hello everyone. Today we'll be talking about reimagining the future of development, which is AI-driven development lifecycle. My name is Harish Mandhadi. I'm enterprise support leader at Amazon Web Services. So today we'll be talking about how AI is disrupting the development. We'll talk about what are the things that are working, what are the things that are not working. We'll get into a little bit more details on that, and we'll introduce a little bit more on AI-driven development lifecycle and the methodologies and different phases and stages within it, and how it revolutionizes the current development that we have. And we'll be talking about some of the critical lessons and the observation that we have seen when interacted with a lot of customers and thought leaders. And we'll also talk about how to measure the effectiveness, and then we have a call to action, and I'll try to provide some resources around that as well. All right, so how is AI disrupting the development, right? So there is like a lot of stuff that's going on within this space, especially like now there's like a lot of tools coming every day, every week, and at a very rapid pace, right? So everyone is kind of like a curious, like where how they should be prepared, and there's like a lot of different personas. For example, when you talk to engineers or thought leaders, everyone has some kind of like the same question and how they should be prepared, and there's like a lot of moving parts around this. For example, if you take a look at engineering persona, when you talk to them, they understand that AI is disrupting the development, but how does it affect them? Like, what should be they doing, right? So do they need to do some kind of like upskilling, or do they need to do some kind of like a training, or where do they fit, right? Should they be doing something else, or like do they have to pivot something that they have been already doing and do something else? So there's like a lot of questions around it, and they wanted to know like how they should be prepared for this disruption, right? So same thing, the different persona, when you talk to thought leaders, even they wanted to help, but they want the teams to be AI native, and they want to scale as well. So what does that mean to be AI native for a developer or engineer, right? So there's like a lot of questions around this, and hopefully we'll try to provide some facts and observations on what we've seen throughout the presentation, and we'll try to see what is working and what is not working as well. So one of this interesting thing, typically, when you use, people have a perception that AI can make things faster. But Meta.org, which is a non-profit organization, has decided to test this scientifically, right? So they have created an experiment with 16 open source developers or engineers, which are senior engineers, and they are divided into two groups. One group is provided or equipped with AI tools or the coding tools, and the other group which is not equipped with any coding tools, right? And they have given the same set of problems, around 250 problems to solve. And after the experiment, the group with group A, which has tools built in, which has access to tools, we're asking the question around how does they feel about the productivity, and they were mentioning around they felt they had 20% productivity. They felt like that, right? So then after the experiment, when they collected the data and analyzed, it's an interesting news or interesting thing that they observed is the group A, which has access to AI tools, is 20% less productive than the team which has no access to the tools. They have been doing the same thing before the AI era, just like agile processes. And does that mean that AI is not working in this case? No, that is not the point. I think let's get into details of what are the things that are not working. We should not say that AI is not working in this case, right? Let's try to unfold why AI is not working. But this is an interesting experiment, and you can take a look at it later on to get a little bit more details. But let's try to unfold what is not working, right? So developers or engineers use AI currently in two approaches broadly. So we kind of segregated into two buckets. One is AI managed, which is AI builds the software with least amount of human interaction or no human interaction. In that case, AI does a lot of assumptions without human, right? It just creates a lot of code that you might not even understand, and it just throws a lot of code at you, and engineers will not be feeling confident because there's a lot of assumptions that was made by AI, which is not in tune with the humans, right? So in that case, the engineer will not be engineers will not be confident enough to accept that code or own the code and put their name during the check-in. So that's why, you might not be seeing a huge productivity gains using this AI managed methodology. So this method works really seldom works, and it's unreliable and unexplainable, because everything is managed, and with least amount of human interaction, it doesn't work that way, because in real world there is a lot of collaboration and decision making that is done by the human, so which is kind of missing in this methodology. So that's why this is one of the pattern we observed, that AI is not working great in this scenario. So let's talk about the second methodology here, which is AI assisted, which is contrary to the first one, which is AI managed one. In this case, human does the heavy lifting. Human does perform all the intellectual heavy lifting and apply AI in a very tactical way, in a tactical fashion, where they might be applying AI in a very narrow task, right? Maybe writing some business function or something like that. But all the heavy lifting, including planning, decomposition of tasks, and story creations, everything is done by humans, and they are just following the same methodology, just like in agile era. In some cases, it's better than AI managed approach one, but they're not seeing a productivity gains like a paradigm leaps, right? They're just seeing in a step incremental, because they are just optimizing the part of just writing the code, but rest of the other things are still as it is, and they might be blocked with a lot of meetings, a lot of plannings and story creations and all those things. That takes a lot of time. So development is not only about writing code. There's a lot of things which people doesn't talk happens in here. So in this case, they might be better than the other one. They see the productivity gains of maybe 5%, 10%, but it's not a paradigm leap. They just saw the step incremental of that. So that's another way. We have seen AI is not working to the expectations of paradigm leap. They wanted to change into multiple increments and see a paradigm shift into that, but they are not seeing that as well in these methodology as well. So then the real question is how do we achieve a paradigm leap rather than having a step increment while having humans in control, right? Then that's where AI-driven development lifecycle methodology comes into. So typically you have two approaches. One is AI assisted and the AI managed. This sits in between AI, both of those, right? We just need to take the best of both worlds. That's where AI-driven development fits into that. So basically what it does is, when you in general human interacts with AI, so human prompts AI, but in this case AI prompts human to think, right? So AI does orchestrate the development process, task planning, decomposition, architectural suggestions. Everything is done by AI, but it will ask the humans to validate that. So it's simple. It's as simple as, instead of humans prompting AI prompts human to think and validate and provide the judgment and oversight around the planning that was done by AI. So that's the difference, and that's the methodology that which is kind of what we see. It's working really well. And with this methodology, you'll be the flow is really simple. Humans have an intent, right? Then AI orchestrates the intent into and tries to decompose that into a task, and then human validates that. So human validates, until human validates, nothing is been written, nothing is been executing the code or writing the code, until and unless human actually validates the plan that was created by AI. Nothing is going to write, right? So that's where humans have the full control over that. But there are core principles of this methodology, which is the operating model for AI. Like I mentioned, AI orchestrates the development process, but human is in the loop every step of the way, right? So humans have the intent. So if you look at the flywheel here, humans always start with an intent. So AI creates the plan here, and then humans verify that plan, whether everything is good, they are missing something, or do they need some kind of like additional oversight of like what's missing out there. And humans provide all this information and judgment to the AI creation plan, and then AI takes that feedback and refines the plan again and just provides you until like human actually validates and finalize the plan, right? Then like AI takes that plan and executes the plan. Then again, like human or verifies the outcome, and it's kind of like a flywheel, right? Like human is always within every step of the way before AI taking the control. In this case, human has the central control, but AI does all the legwork for you. So that's how the methodology spans in here. Ultimately, like developers have the ultimate responsibility of validation, decision making, and oversight. Because of doing that, the developers will be feeling so much confident, and they can own the code, and they are feel so much confident because they are part of the entire planning, execution, and testing, whatever that is, right? Throughout the flywheel. So that's how they feel the confidence in this. So this is the operating model for AI, right? And we have an operating model for human because we are taking the best of both worlds, right? So the another interesting thing, where do you think time goes in SDLC? So we have seen that writing code is only 20% of the development cycle, right? The rest of the thing happens with everyone just waits for everyone else. So if you think about it, security team will be a gatekeeper for any kind of development that needs to go into the production, because they want to make sure that they have the threat modeling in place, right? So if you look at the operations team, they are always waiting for development team to release the code, right? And the same thing, QA environment, they are waiting for development for the code to test. So it's kind of now everyone just waits for everyone. That's kind of you take a lot of time in building in from an idea to shipping the product to the market, right? So you are seeing there is a lot of dependency that's happening over one team. This how do we break these dependencies, or how do you short circuit these dependencies, right? So that's where we have operating model for humans in order to break and short circuit some of these dependencies across multiple teams and multiple people around it. So we'll talk about a little bit more on the operating model for humans. So there are a couple of methodologies that we have in order to operate the human part, because we wanted to reduce the human dependencies and the teams across the different teams, right? Typically what we do is the mob elaboration is a methodology that we incorporate in this operating model of human by bringing all the stakeholders into a room. Maybe it's a one-day event or something like that, or maybe 4 hours. We bring all the stakeholders from business, from product team, developers, and operations. So we bring everyone into the team, into the room, and apply the AI methodology. What AI methodology does it? So again, by cross collaborating everything, we call it as a mob elaboration. So AI does the legwork for the mob. So but humans and the collaborated teams which are in the room will have an intent, and then AI prompts these mob to think, clarify the plan that they have, and make sure everyone is on the same page. So if you think about AI has a brain and humans has a brain, what this step does is by collaborating with multiple people and multiple stakeholders, we are trying to make sure everyone is aligned in the same fashion, right? So AI has a plan, and you are providing some oversights and insights. Now at the end of this, the outcome of this methodology is everyone, including AI and the humans in the room, cross collaboration teams, they have a unified vision and validated vision that they wanted to proceed. And with this, it also provides the units of work. So the outcome really is validated vision across all parties, and units of works was designed by AI based on the orchestration that it had done. The next phase of mob elaboration is mob construction, which is you take before. So every step is kind of a refining into the next step, which is more context, and it gets richer and richer as we pass from one stage to other stage, right? So coming to the mob construction, this is where you take the validated vision that we have from mob elaboration and the units of work, and you spread that units of work across small different teams, and even that individual teams has people from different departments, different cross collaboration team, maybe a security developer and operations team working together as a group and trying to finish up the units of work, maybe like different functionality within the service or something like that. So that's how you see the groups around it, and they just work towards getting things done. And one of the outcomes for this is like the assets and the domain driven models, or like CI/CD and testings, the definition of done, everything is done through the mob construction, and you have a production grade output code, because like you solve the human problem by bringing them everything together, and also you're not depending upon multiple teams, and you're trying to solve this using this mob construction phase as well. So that's how you solve the human problem and the dependency and short circuit the waiting cycle, and that's how like you see the production gains in here. So if you put everything together, the methodology of AI-DLC, like we talked about mob elaboration, mob like construction and the operation, let's try to put together as a full cycle. And AI-DLC has 3 phases, which is inception, and the inception is something similar to mob elaboration, and the outcome of that inception is like a validated vision, so that like AI brain and the human brains aligned on the validated vision and the units of work. And then the construction part, which whatever the validated vision from inception phase is taken into and segregated into different groups, and each group will be taking care of different functionality, and they can come up with production code, testing scenarios, integration scenarios, and try to deploy. And then the operation is like they're trying to deploy that through an CI/CD mechanism. So these are the different phases, and each phase has a different stages within it, which we'll be talking in the next slide, and each phase gets richer and richer as it passes from top to down. So if you elaborate a little bit more on that, so inception has like I mentioned, users, humans has an intent, and you take that intent and orchestrate the plan and come up with the user stories, and the outcome of that is a validated vision, and which is validated by humans, and also like which is aligned with AI. So basically what you get is the planned units of work, and you take that units of work, which might be set of similar user stories which are grouped together, and you call it as a units of work, and you take that units of work and segregate into different groups, and you assign those units of work to different groups, and then each group again, like each group contains different cross collaboration team which are sitting in the room, and they will be divided that into subgroups, and they'll be providing assets, which is like domain modeling, whatever the data driven models, and they generate the code and test, and if there's any kind of like architectural components, so they kind of like create all the assets needed for the code to get deployed with like infrastructure as a code, and try to do all the testing. And then once you have passed this, then it deploys the production in the operation phase, and you manage the instance, and it's kind of like a flywheel then that goes with and these phases and the stages are very adaptive, like every feature or like every bug doesn't have to follow all these phases, like for the new features, like it might follow all the stages, but for a bug fix it doesn't have to follow all these things. But so we took all these stages and phases and try to codify into rules. We call it as steering rules, so which is open source, by the way. I can provide you the details later in the call resources. So we took all the methodology, whatever the mob elaboration, mob construction, inception, and the operation, and all the stages and phases within this particular slide, and we kind of like took everything and codified everything into rules, so that like any coding tool, whether it's a Kiro that you have, whether it's a cursor, whatever that is, that the coding tool that you guys use for the development purpose, you can import those rules, so that whenever you are interacting with AI, so it just checks all the rules which are ingrained as a kind of like practices. So this is how like we can ingrain AI DLC into the new era by taking those rules and try to be more adaptive with the new features, and whether it's a bug fix or the new feature that we are trying to develop. And by the way, like it fits great for like greenfield problems and also brownfield problems, and we have tried that. So if you look at it, software development pathways always with greenfield. So for those people who don't know, like greenfield is nothing but if you're starting something from scratch, then it's called greenfield. If you already have the code base, legacy code base or whatever that you are trying to insert something into that, then we call it as a brownfield. So most of the cases, you might be looking on the brownfield side. So this methodology that we have tried with a lot of customer works great for both greenfield and also brownfield. However, there's a challenge that we need to make sure for the brownfield problems that AI understands the code. So for which, because we need to because it's a lot of legacy code that's sitting in, you need to make sure you need to make the job easy for the AI so that it will help you to in return, right? So how do you do that? So for a brownfield legacy problems where you're already sitting, repository has a lot of code and you're trying to insert some new features or the bug fixes or whatever that is, and how do you do that with this methodology, right? So we find that working really well by a couple of techniques, right? When you're trying to make sure you're making sure AI understands this brownfield code which is already sitting for years. So what you can do is you can feed AI using reverse engineering techniques and call graphs, or maybe what are the dependency components for this particular let's say for example, if you're having e-commerce website or something like that, what are the depending components for the order order service, right? What are the different components which are related or interact with the payment services? So you kind of drew a call graph or dependencies and write it in a high way so that it has a meaning on it, exactly know what to do when we need to change, for example, an order service. So AI should not just search for order and just change all the files which are related to order, right? So there should be a call graph and dependency mapping that you should provide and feed it to AI so that it helps you not changing all the files but only relevant files which makes sense for the product feature that you are developing, right? So that's how you train or provide information for the AI for the brownfield problems. But we have seen it works great. This methodology works great for both greenfield and brownfield as well. So some of the lessons, let's discuss about some of the lessons learned, which are do's and don'ts. So these are not best practices per se, but these are some of the critical observations that we have seen, and it worked really well if you focus on some of the things that you should be doing and you should not be doing as well. So think beyond the vibe coding, because developers or the engineers currently work isolated, they work in silos and they get into a vibe coding loop and vibe coding cycle where you prompt AI, it provides tons of code you don't understand, then you provide the feedback and it does something in the back end and tries to come up to you again. So it just gets into the vibe coding loop, right? So we wanted to think beyond vibe coding, use the practices like AIDLC and mob elaboration and mob collaboration and mob construction, trying to make sure bringing the people together and working together and make sure AI orchestrates the mob and help you to solve some of these problems where human has the control and human will feel confident when they own the code, right? So you think beyond the vibe coding and not work in silos. So that's the number one. So the other one, which is maximizing the semantics to token ratio. What does that mean, right? So whenever you feed something or you ask something to AI, just make sure you have a rich semantics context for AI to understand. Because, for example, if you're asking AI to have refactor this particular component into a builder pattern in Java framework or something like that, right? Whatever that is. So here the example that the statement that has high semantics to token ratio, right? Because the refactor is really rich in semantics, builder pattern in Java is kind of really rich in semantics. So you need to feed those kind of make sure maximize the semantics to token ratio. Rather if you do something hey, I need to build an utility where you have setters and getters, where I just need to receive some information from the other object and build a complex complex object. So this has a lot of information which doesn't have a good semantics or the context. So you're in this case, like the semantics to token ratio is really low, because you don't want to tell AI in such a way that there is a lot of less semantics to token ratio. So always make sure you maximize the semantics to token ratio, meaning you provide the, sometimes it's better to provide the meaning rather than throwing tons of lines of code or maybe documentation to the AI, right? So that's very important. The other thing, which is refreshing, rebuilding context strategically. So a lot of people think having big context helps them, but no, it's not always correct, because sometimes AI gets confused with more context. So you need to make sure you always trim and check what's in the context, and make sure you get rid of the context which is not necessary, right? So that's another one. And so for the brownfields special context, like I mentioned, you need to do the reverse engineering for that. You need to provide call graphs and dependencies, and what's the starting point of the function, how do you trace that back. So if you provide that rich set of information back to brownfield problems with more context, it will help you. So the ethos that we follow is make sure you help the AI, it will help you, right? So that's how you follow the context setting for brownfield problems. And for the refactoring with surgical precision, so this is where we talk really about when we are dealing with a lot of legacy code, and if we want to change anything, a lot of people has an inertia to touch the legacy code, because people might have coded and they left, right? So no one knows how things work, but it just works. So make sure we can change that idea, right? We can change that inertia to make changes by leveraging AI using the AI DLC process. So what you can do, you can apply the reverse engineering techniques that I was discussing about, and understand the semantics by having an interaction with human. Make sure we validate with the mob again, and then you have a clear understanding of what this legacy code does. And once you have that information, you feed that information back to AI and do the flywheel again. You have the intent, you have the code graph, call graphs and all the code, and you wanted to do a certain outcome, so you just follow the same thing, bringing all the people together and into the room, and you express that to the mob. So that's where you have some of the things that you do, and some of the things that you want to do, and some of the things that you don't want to do. And then ultimately you own the code, right? Your name will be on the check-in, so you just need to be comfortable. And if there is in a page that comes in, you need to able to debug and troubleshoot some of the issues, whether it's an AI written or you have written. By following the AI DLC, human has the control and full understanding of that. So make sure you follow this methodology. So the other big question is how to measure the effectiveness. A lot of thought leaders wanted to know how do they want to measure the effectiveness. It's the same thing as in agile era. So AI in the developments are the measure outcomes rather than outputs, number of cones, number of code, number of lines accepted, or developer accepted doesn't mean nothing, right? So make sure you measure the right outcomes, which is the velocity with the time taken, the time it takes to deliver an idea from idea to shipping into the market. So that's number one. And the quality and velocity goes hand in hand. Just make sure you have the right quality and the great customer experience, and the reliability and the usability of the feature that you are trying to ship it. And the predictability is another one. Number of predictability means number of sprints committed versus number of sprints delivered. So in the agile era, it was close to 30 to 40%, but in the AI era, with the new methodology that we have seen, that it can reach up to 70 to 80%. That's how you can really see the paradigm leap around that. So measure end-to-end delivery timelines. So we don't need to people will be asking where do I start? You don't need to over-engineer this. So people can just take whatever it's in the backlog, and just they can just come take the backlog and do the regular processes, which is if they are doing the story estimation or whatever that is. So you do that with the regularly what you are supposed to do, and then you include AI into whatever that you have planned into, right? For example, then apply the AI DLC methodology with the different processes, bringing people together, and then measure what was planned versus how we delivered. Then you have an A/B comparison between two things. then you can say like whether it's a 50% faster or like 30% improved or whatever that is. Then you can come to the consensus yourself, and you can scale across this to all the teams, and you can average it out across the organization to get a realistic number of the production gains. All right, so like I mentioned, all these things that I was talking for the last 20 minutes is being codified, and it is open source. You can find the rules, steering rules in the AIDLC with this Git repository, so which is like open source, and you can take a look at it. All the workflow that I was talking about, all the stages, everything is ingrained within these rules, and we have codified that. You can take this information and import into your coding tools, whatever that is. It is Kiro from Amazon, and if it's like a cursor or whatever that is, so you can import that and do all the processes in order to incorporate AIDLC into that. So that's how you can beat the traditional workflow where you cannot see paradigm leap of productivity gains. With this new methodology of mob collaboration, inception, construction and operations, you can definitely see a huge improvement in the productivity again, and you can achieve that paradigm leap with this process. All right, these are the resources, and yeah, that should be it from my side, and thank you for listening to this talk. Thank you.